Welcome back again. So this is lecture 4.2, so this is the third part of the nested if statement lecture. Have to pause every time to make sure I don't say nested loop. I do not say it this time. So we're going to do a circuit model example, and so I'm going to use a little program called Logism, and I'll show you that in just a second. So let's take away this text and show you the program. So this is not coding particularly, but it is logic in a sense. And so what we're going to do is we are going to basically replicate these circuits that we can have. We'll replicate the circuit in code. So let me show you what I mean by that. And we're not going to do anything terribly complicated. We're just going to do a very basic example. But so this symbol here is, I think I can put a label on it. I'll just put a label on it, and okay, didn't like that. Oh. Okay. So I just want to label this as an AND gate. The reason why I want to label this as an AND gate is because you might not be so familiar with these symbols. I'll label this as an OR gate. So the way that this works is that the two inputs have to be true, and then the output is true. Here, one of the inputs has to be true, and then the output is true. So let me show you some examples of how this is going to work. I think we can, so these are the pins, these will be inputs. And I think we'll name them. We can name them, this one, name it A, name this one B. Maybe name this one something really creative. C, I don't know, let's go nuts. D, all right. So that was fun. So I think we could zoom in. Yep. Yep. Zoom in and go up. So here what I'm going to do is I'm going to connect these gates like this, just to show you how all this is going to work. And then we are going to take these two. Basically, these are wires, but we're going to put a probe here. And probes are just reading the, or I guess actually we could also use output pins. Probably just as good. Let's set output to yes. So let's make, so we have input pins and output pins. All right, so let's see what happens. So I think there's a little finger, yes, that I can poke these things. So if I poke A, you notice that A is true, the AND gate is still false. Make B true, the AND gate is still false. But if I make both A and B true, oh, now it lights up, now it's true. Okay, let's turn that off. Let's go here, OR gate. False because both of them are 0. True, true. There we go. What if both? Yep, there we are. So I guess the last one we need is the NOT gate. So let's make a NOT gate. Let's label E, true innovation, right? True innovation. So here we have our NOT gate. So it's coming in as 0. And remember that this is a true literal interpretation of the fact that 0 is false and 1 is true. Now, in electrical engineering or computer engineering, normally 0 is going to be a 0 volt difference, and 1 is going to be a 3.3 volt difference from the ground, or a 5 volt difference, or think like 1.6 volts sometimes. Basically, some number of volts, probably between 0 and 12. So here, if I flip this, Now, E is true, or one subscript B for binary, and you see that the NOT gate is false. Flip it back, NOT gate becomes true, right? There we go. So let's make a little if statement out of these types of gates. So let's take ands and or gates and do something with this. So let's say we have let's see what happens when we do something like this. So of course this is red because it's undefined, but who cares? Let's yeah, let's pretend that these are A. I think will it yell at us for having a duplicate? It does. So let's take the labels off of these so that it doesn't care. So now let's say that this is A, this is B, and let's take the label off of C and take the label off of D, take the label off of E. There we are. So now we can deal with letters as we want. So let's put another one in here, and let's say that this is now C. Let's do something simple. So here what we're going to do is we're going to model this as an if statement. So basically, how is this going to be true and false, right? And so this will be true. Oops, didn't mean to do that. This is a single if statement, okay? Now, how do we think about this as an if statement? So what I mean to do if this is an if statement is remember that these two things are going into an and statement, and so these have to get anded together, and then their output gets ORed with C. So let's think about how to do this. So we're going to have to do A and B, right? Think we can do. And then we need an OR C, right? But we need the output from both A and B to be ORed with C. So just to be careful that there isn't a problem, what we can do is we can put parentheses around the A and B, and then we know that whatever comes out of A and B is going to get ORed with C, and that should do it for us, right? So let's let's code that up in Python. So let's say input enter A, and we'll just cast them to integers. And remember that integers are true if they are non-zero and false if they are zero. So enter A, enter B, enter C. And so here we'll enter C, and then we'll say if A and B or C. Print yep. Else print nope. So let's play a little bit with the circuit. And of course you might say, but hey, we haven't nested anything yet. Well, that's okay. We'll nest stuff in just a second. So here, let's see what happens. If you turn on C, so if C is true, this should be true. If you turn off C, it should be false. Okay, cool. So turning on C makes it true. Turning on B doesn't do anything. And by that I mean turning on B alone doesn't do anything. Turning on A and B will turn on this AND gate, which turns on the OR gate, which makes it true. Turning on all three makes it true. Turning off one of these doesn't matter, right? As long as C is true. Now if C is false, and you have an alternate condition, then there you go. And if everything is false, then it's just zero. So let's test out a few of those and make sure that our circuit matches our if statement. So enter A, we'll enter that as 1 for true. Enter B, 1 for true. Enter C, 0 for false. And so remember that the A and B should come out true, and then C should come out as false, but it doesn't matter because it's an OR statement. Technically, you might even say this gets short-circuited. Let's enter A and B as false, C as true. This should come out as true. Yep, it does. How about A is false, B is true, C is false? This should come out as false, right? How about A is true, B is false, C is true, right? How about this one? So the AND gate will produce a false, but the OR gate at the end will produce a true. So remember here that the OR gate comes after the AND, so it's after the parentheses. So it's the last thing that the logic feeds into. So the OR gate is kind of the controller here. AND gate happens before that. So that should work. Of course, if you go 1, 0, 0, that should fail. And then 0, 0, 0, that should fail. Okay, so we're pretty convinced. All right, so let's make something else. So how can we get a nested statement? So I think one of the ways to get a nested statement out of this kind of circuit logic is to, let me build you a circuit that I think might require, I don't know if it absolutely requires it, but we can make it as a nested loop, or a nested if statement. So let's try to do that. Okay, let's take all that out. And then let's put in a NOT gate on A, and then let's OR it with that and B. And then let's AND it with this, with C. And then finally, let's add maybe 2 more input pins. So let's say D and E. Do something like this. So here, let's put these pins here. So let's pretend like we don't get the inputs from these pins until after we do the rest of it. So let's say that these two get ANDed together. Guess I should move this one up. There we go. And then finally, let's do this and just see what happens. Let's try to get that symmetric. Good. Symmetry is important in life. So let's write this. So I think we can write this as both a non-nested statement and a nested statement. So let's see us doing it as a, let's try to think about this as a non-nested statement. If we think about it, let's do non-nested first. So basically with a non-nested statement, this is not A going into here, so we get not A or B. So that's the first condition. And then that feeds as one of the inputs into an AND statement, and C, right? And then that feeds as one of the inputs into this OR statement here. And then we have to worry about the other side. So the other side is D and E. So remember that the straight back is AND, so we get D and E. But actually, there's a little knot on it. So we actually have to put a little knot on D and E. So this is the non-nested version of the statement. So this if statement here, or this condition, is the same thing as this circuit diagram. But maybe you're thinking that this is a little bit complicated. So you want to implement it as a nested if statement. So there's a way to do that too, and I think it's kind of prettier in a way. It'll help us out. So let's put this here, put that here. Got to do this to make room. You got to kind of space this out. Let's see here. Got to zoom out and move. There we go. So let's code this if statement here. So we go if not A or B, right? And C, or not D and E. So this will do it. Of course, now we have to enter D and E. There we go. Print. Yes, that is true for some reason. And otherwise, you might say print. No, it's not. But on the other hand, right? Maybe you think that this condition is a little too complicated to just be one big blob. And of course, it's not just going to be A and B. These are going to be variable names, so it's going to stretch on. It could end up being pretty complicated. So this is the non-nested version. Let's do a nested version. So I would say that we would break up this OR condition. So basically what we're going to do is, well, actually, so we'd actually need a nested version. Don't need one for this. Because watch what we can do with an OR statement. So what we can do is we can say if not A or B and C, print yes, first part true. And instead of doing a nesting condition, which you might have to do if this were an AND, with an OR, actually all we need to do is just an ELIF. We can just say not D and E. So yes, second condition, else print false. No good. So if you think about this, why are these two equivalent, other than the fact that their prints are different? But why are these two kind of logically equivalent? They are because here, this part of the condition is right here, and it gets evaluated the same way. And if it's true, then you do this first part here. Now, of course, this says two different things. So, but this OR statement says OR not D and E, so you have OR not D and E like this. And so if you had them actually print the same thing, then this would actually be exactly equivalent to this. The only way they're different is because this gives you a little bit more control over what exactly is true. If the first part is true, then you can do this thing. If the second part is true, you can do this thing. If you really don't care, you can stick them together with an OR statement, even if they do the same thing. If it's a single line of code, sometimes it still makes sense to break them up just so that you can see that the conditions are separate. So ELIF is actually performing kind of an OR function here, which is an interesting thing to think about. Okay, so let's design one that is more amenable to nesting. I just made this one at random. So let's make one more that we can nest, and then we'll end this example and go on to the second example. So yeah, let's make something we can nest. So I think the way we can make something that's nestable is if we say, put the AND gate last. And you'll see why this is more nestable in just a second. So let's put an AND gate last, put a probe on it, to read the result from the AND gate, which is currently error. So let's pull some gates and see what happens. So AND gate, or gate, not gate. So let's not E and let's not C. And then what I'm going to do is let's OR this one together with D for some reason. No particular reason. Let's AND A and B together. Again, for, you know, no real discernible reason, just that I feel like doing it. And then let's actually AND these two things together before we then stick it on as an input there. So that'll help us out a little bit. We can do this. We can do this. We can maybe do this. And then finally we'll stick this input in here. I think that does that look symmetric? That or good? I think that looks fine. Okay, so let's think about this and see if we can make a nested if statement out of this. So let's get rid of this old answer. So this new one, if we wrote it all as 1, the first thing we do is we do A and B, and then it gets ANDed with, so here we get not C or D. And then here we get a not E. But remember that here, all of this stuff gets put in the second part of the AND gate. So here we need this to be in parentheses. Technically we don't, because this is statement and statement and statement. As it turns out, and is associative, so we can drop the parentheses, but I'm going to leave them in just because I feel like you might feel a little bit safer. It's also kind of the order in which I'm going to do things in, so I don't want to steer too far away from being maximalist with parentheses. So basically what I'm going to do, that's actually, I like that better. Yeah, that's better. So here's how we could implement this. So basically, if we have, for instance, if A and B and not C or D and not E, right? So that print, this is the if statement. But here's how to make a nested version. Right, so what we can do is we can first test if A and B are true, and if that's true, then we can then test if the second part, so I can just copy paste the second condition, like this. Python doesn't like the extra parentheses. It's a PEP 8 standard that you don't include them. It's up to you, really. We're not going to enforce that standard too harshly. So here you notice this is the if statement, also needed, right? Here's an else print. It's partially true, but not good enough. And print here, else here, you can print, no, this is totally false, right? Here we don't have we can't determine whether or not one half of the statement is true here. All we can do is print, saying like, yep, this is totally false. And so that's really all the choice we have there, because we didn't nest. Now, is one better than the other? The answer is depends on your needs, depends on what you're doing. I'm just trying to show you the equivalence between these two things. So let's play around with the circuits and see if we can come up with a true value. So to make this thing true, these two need to be true. There we go. Oh, that was easy. So let's see what happens. And this is particularly good if, for instance, the input, this would be necessary if inputting D and E are done here, right? If you inputted D and E here, you couldn't make one single if statement because you would know A, B, and C, for instance, but you wouldn't know D and E. So you would actually need to evaluate it later. So you evaluate A and B, you input D and E, and then you evaluate the rest of the statement. So for instance, let's check this out. So let's see here. Let's enter 1, 1, 0, 0, 0. So remember that yep is coming from all the way up here. So let's look at what happens to all of our statements. Really, we only care about the last thing that prints out, or maybe the last two things. So you see here, it says, this is the if statement that we need. This is the if statement that we also need. So let's try another condition. So in this case, oh wait, there's no way to make it true without, both A and B, right? So let's flip A and B both to true. Let's flip the rest of them to false. Oh, the rest of them don't matter if A and B is true. Oh, they kind of do. Okay. So here if we flip these, so if we go true, 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 false, true. So true, 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 and ignore that one. That one's from the original problem. False, true. So only pay attention to the last two lines, I guess. We'll get, this is totally false. And then here we get, actually, it's partially true, right? Because we've set the first two things. This whole statement here is totally false, right? Because it only takes one of these two branches of the condition to be false to make it false. On the other hand, here, we're evaluating A and B separately, then we're evaluating the rest. So there's kind of there's a sense of partial truth here, whereas here, you have two branches of an AND condition. They both have to be true for it to work. So I think that's about it for this example. I think we've nested some stuff. I'll probably do one more circuit example, and then I will do a final example on nesting, and then that will be it for nesting. So come and join me in the next nesting video, and we'll talk more about nesting examples.